Right, chaps. Today an easy lesson. We're continuing with integration, and today we're gonna integrate exponent function, e to the x to the power of x. Now that is extremely easy. Why? Because if you remember, if we're trying to find the derivative of exponent, okay, the derivative is simply the same exponent. That's what's cool about exponents. Okay, if you've got a function e to the power of x, the derivative will be e to the power of x. That's from your table that you get for as a formula sheet. So that means that if we're looking for the integral of the exponent of x, well, we're going to get back our function. So the integral of e to the power of x is e to the power of x. Okay, so whether we do the derivative or if we do the integration, we get the same thing. So now what happens when we've got constants? Okay, so obviously it complicates things a little bit. Okay, so we're going to integrate e to the power of 2x. So you got to think about it. Okay, we're going to have a function, just like we do the sine and all the other things. The integral of e to the power of 2x is going to be e to the power of 2x, but with some kind of constant. Let's look at that. So if I take e to the power of 2x and I do the derivative, what are we going to get? We're going to get e to the power of 2x time, using the chain rule, time the derivative of the inner function, which is 2. So 2 times e to the power of 2x. But I don't have that time 2. So I want to get rid of that time 2. So I'm going to have to divide it by 2 to get rid of it. So in other words, the integral of e to the power of 2x is going to be e to the power of 2x divided by 2. Okay, so I showed you that once like this, but from now on we can hopefully do that without this. Okay, so I'm suggesting a solution e to the power of 2x. Okay, when I do in my mind the derivative, I know that the 2 is going to jump out, so I must be prepared and have something to it. As it comes out, we'll divide 2 by 2 and it will be that will be the answer. Okay, obviously Olivia's not here, so she's not here to remind me that I must have plus a constant. Okay, every time we have an indefinite integral, we have plus a constant. Okay, what about this one? Okay, so again I have an integral of the exponent, so I can think, okay, the function is going to be function that I suggest will be the same exponent, okay, plus the c. But now I'm going to think about, if I do the derivative of that, I must get that. So okay, if I do the derivative of that, I will get that, time the derivative of the inner function, okay, which in this case is going to be 3. So 3 is going to jump out of here, so I must divide by 3. Okay, I'll pause here, make some space. Okay, so 2 more examples, not much there. So now I've got an exponent, but it's in the denominator. So as always, also we have the same thing with the polynomial. If I have x to the power something at the bottom, it's better to just leave that for a second and rewrite it now with negative exponents. Okay? So I'm looking really for the derivative of 4 times e to the power minus 3x. Okay? So I'm suggesting a solution, and my suggestion will be that it's going to be x e to the power of 3 minus 3x. Okay? The derivative of that is simply that. But now I've got to ask myself, right, when I do the derivative of that, okay, the minus 3 is going to jump in. So I need to divide that by minus 3. Have minus 3. As I do the derivative of the inner function, the minus 3 comes out, cancel out. But now I don't want to have 1 here. I want to have 4. Okay, so the answer will be that. Okay, and obviously I'm adding my c. And let's look at it again. If I do the derivative of that, according to the fundamental law rule of calculus, I should get what I get here. So I'll do the derivative of this. I'll get e to the power minus 3x. Time minus 3 will jump out, get cancelled by, get ambushed by that minus 3 here. Get cancelled, and I'm still left with a 4. Okay, I'll just check that I've got it right. If I can find it. Minus 4 over 3. Fantastic. Obviously, the minus, we can just put minus here. It will be nicer to put it like that. Right, over here. Now, when you've got something like that, you know, the problem could be that you start thinking about, okay, I've got 2 exponents. They're completely different. How does that work? Don't forget, that we can simplify this. I can write that as e to the power of 3x divided by e to the power of 2x, right? That divided by that, plus 4 times e to the power of 2x. All of that dx. Okay, so, and obviously when it's here, I've got integral of the sum. That obviously is equal to the sum of the integral. So it's going to be e to the power of 3x divided by e to the power of 2x plus that dx, okay, mustn't forget that dx, plus 4 dx divided by e to the power of 2x, okay? Get some more space here. Right, now let's write it a bit nicer. So what is e to the power of 3x divided by e to the power of 2x? So rules of exponents are going to be e to the power of x dx, right? 3x minus 2x is just x, right? And the next one, I'm going to rewrite that as 4 times e to the power minus 2x dx. And let me just see that you can still see that side. I think so. Let's move you a little bit. Yeah, here we go. Okay, so let's write again. What is the integral of ex dx? That's the easiest one. That's just ex. Okay? This is if I move from the derivative to the function, that's, we know we started the lesson like that. Plus, okay, I've got a feeling it's going to be minus, but let's start with the plus. Now the integral of something times e to the power minus 2x will be e to the power minus 2x. Now I need to think, okay, so when I do the derivative of that, I need to get that. So I need to have, first of all, 4 there, that will eventually last. And I need to divide by minus 2, right? So as I do the derivative of that, minus 2 will jump up, gets slashed by this minus 2, and I'm left with a 4. So let's write, and obviously plus a c, okay? I don't need to add a c for each integral, it's just a general constant. So the answer will be e to the power of x minus 2 e to the power minus 2x. And I'll just see that they got that, and I think, yeah, that's all good. Okay, plus a c, plus a c, plus a c. I think that's it. Right, I will write down one more thing. Yeah, something that they wrote here. So I'll write. I'll just pause. It'll make some space. Okay, so I'm just going to write that down. It's not going to be that helpful, but you know, I think you've got it in the book, so I might say that. If you've got the integral of e to the power of some kind of function, and then here you got the derivative of that function. The integral of this crazy stuff is simply e to the power f of x. Okay? Let me just show you why that is. Okay? The fundamental rules of calculus tells you that if you've got an integral that gives you a certain function, if you do the derivative of that, you should get what's inside the integral. So I'm gonna just do def of x to dx. And according to the chain rule, what you'll get is e to the power f of x. You'll get that, and you'll time it by the derivative of the inner function, which is exactly what's in the integral. So I proved that. Now that's not extremely useful because we don't know what's the f and what's the f of x, but it's basically what we've been doing. I'll just show you one case. For example, if I looked at the integral of 3x dx, okay, and I had 3 here, I had an exercise like that. What is that? In this case, f of x is equal to 3x. So that means the derivative of 3x is 3. So now that is the f of x, and that is the derivative of f. So the answer is going to be e to the power of f of x, in this case, e to the power of 3x plus c. So it's a formula, it's a nice looking formula, but we don't tend to use it. Hopefully that made sense. I'll see you. That was a short lesson. I'm going to do another one for integrals of logarithms. Cheerio.